Linear programming, and we're going to go over the basics of linear programming. What linear programming means is that basically you are now dealing with inequalities and systems at the same time. Okay, so we're taking what we've been learning for the past 2 weeks and putting them together. Okay, so linear systems and linear inequalities came together and had a baby, and the baby's name is linear programming. Okay. So what do you know? What do you have? What this means is you have a feasible region. Does anyone know what feasible means?
No. Reasonable.
No. Okay, there's a reasonable region where all of these inequalities lie to be true, right? So there's a specific region where this could be true. Okay? Linear programming is usually at a lot of businesses when they're trying to figure out how to maximize their cost and minimize their spending kind of thing. All right? So formed by graphing a, what is it? System? Yeah. Of inequality. Okay? Under these restrictions, you must maximize or minimize. Some other function. So whether it's cost, time, production, that's what you're trying to figure out. How can I maximize or minimize? Okay? What you're going to use are the vertices. Okay? The reason why we're calling them vertices is because when linear functions intersect and you put them all together, they can intersect into different polygons, right? And a vertex is where two lines meet, correct? So we're trying to figure out where those two lines meet, aka our intersection. Okay? But we're calling them vertices because when you look at it, it can look like a triangle. It can look like a rectangle, depending on how many systems you put in. I mean, how many functions you put into the system. All right, we're going to do number 1 by hand first, and then we'll do number 2 with the calculator. Cool? All right, so number 1 by hand. First off, you got to make sure that what variable is by itself?
No, y.
Y. So I need to make sure y is by itself. Well, here it says y is, can you guys tell me what that says? Because mine is blank.
That's equal to
Of what?
Negative 2x plus 4.
Negative 2x?
Yes, ma'am.
Plus 4. Okay, and this one is y is?
That's equal to x plus 7.
Okay, well, what would this one become?
Which one?
How would I get x by itself here?
Oh, you minus 3. No. You minus the x.
Okay. And then?
Divide by 3.
So therefore, y is greater than or equal to? Negative 1 minus 1/3 x. So for each one of these problems, do I not know my starting point?
No.
Yes, I do.
Oh, what?
My y-intercept. What's my y-intercept?
Oh,
that's my starting point.
You not know the starting
point. Oh, I'm sorry. Do I know my starting point?
Yes.
Yes. Do I know my slope?
Yes.
So can I graph this line?
Yes.
Yes. So let's graph the line. So we're going to graph the first one. So what do I start at negative 2x plus 4?
0, 4.
So I go to 0, 4. And at 0, 4, I'm going to do what?
Down 2 over 1.
Go down 2, right 1. Down 2, right 1. Or I can go up 2, left 1. Up 2, left 1.
Okay, negative 2.
We're doing the first one.
Okay, I thought that was negative 2.
It is a negative 2. Negative 2 means I can either rise up and run left or rise down and run right.
So, wait, I have a question.
1 minus negative 1 minus 1/3 x.
We're on the first one.
Still a third.
I wrote negative 1. But 1/3 x. Oh, it's a third. It's just a funky looking 3.
So, what we shade, it'll always be in between them, right?
Yes.
Okay.
You'll see where all of them will end up. So let's graph it. So I'm going to graph the first line. That's a pretty straight line for me. Hopefully your line's a little better than mine. If you would like a ruler, please grab one. Huh? My slope is -2/1.
You were stuff. That's not.
Yeah.
That's the paper I missed.
All right, so I'm going to graph the next line, which is x plus 7. So at x plus 7, I'm going to start at positive 7. And I'm going to go up 1 over 1. I'm going to go down 1 over 1.
You're gonna start at what? How you know where to start?
My intercept?
Yeah. Or down
But you
one
didn't start
over
and stuff on the floor.
Yes, I did. I started at 4.
That's two.
I started at 4. Guys, are we still struggling with graphing lines?
No, this is, no.
Okay, I'm going to graph the last one. The last one I start where?
-1.
I'm going to start at -1. I'm going to go up 1,
Over 3.
left 3. 1, 2, 3. And I can also go down 1 and right 3. 1, 2, 3. Hopefully your line is way better than that. Let's try this again. That looks better. All right. So where these lines intersect are my vertices. Do you get why it's the vertices now?
Yeah.
Because I made a what?
Triangle.
Triangle. All right. So what's the first vertice you can identify?
Negative 1, 6.
-6, +1. What's this one?
No,
-1, 6. And what's my last one?
Negative 3, -2.
Now was that so bad?
No.
No. So I'm gonna write them in.
Where did you get -6 from?
Here.
Okay. But
The verse over here.
mine didn't either. Maybe I did it wrong.
Your graph didn't go to -6.
My yeah, my X, where it crossed there, it's like in the middle of.
It's your line's just a little off, but it's supposed to be at -6, +1. All right. So I write what I have: -6, +1, -1, +6, and I have 3, -2. Okay. This right here is my function. This function could represent cost. It could represent time. It could represent projection, depending on what the problem is. So what this function is saying, C equals 8x plus 11y, guys?
Yeah.
Plus 11y. Well, now I know my vertex is, so I know where this is possible. So wherever x is, I'm going to plug in the x values. Wherever y is in that function, I'm going to plug in the y values. So here, C would equal 8 times -6 plus 11 times 1. And what would I get as an output?
37.
Okay.
I think.
-37.
Yeah.
Okay? Same thing here. Find C. I'm going to plug it in. I'm going to get 8 times -1 plus 11 times +6.
54.
I get what?
58. I got 58.
It is 58. Sorry, smart. All right, and the last one is 8 times 3 plus 11 times -2,
2.
and I get 2. This is what I look at. So when the problem asks, what is your maximum value? What would I say?
58.
58. So my max is
-1.
when C equals 58. And when would my minimum be?
-37.
When C equals,
-37.
and that's how you work it by hand. Now, is working it by hand really that bad?
No.
No. So imagine how easy it is to do with a calculator. Pretty much the same. All right, so number 2, we're going to learn how to do it with a calculator. So take your calculator from the home screen. You're going to open up a graph page. you can just click on the little graph right here, the little blue button, and it'll open a graph page for you. Okay, are we dealing with equal sign? No, we're dealing with what?
Inequality.
Inequalities. So that means we're going to delete out our equal sign, and we're going to put in our inequalities.
Miss Jones,
Yes, ma'am.
my graph is boiling.
Go home and press blue.
Go home.
What?
Go to the home and just open a new graph.
It said that.
Go home, press B.
Go home. Don't press the word graph, but press the picture of a graph. Okay? So I'm going to put in negative 2x plus 4. I'm going to arrow down so it can take me to the next line.
What you do?
Go back.
Okay? Let me undo. So the first thing is I do, I'm not dealing with equal signs anymore, am I?
No.
So I delete it out, and I'm going to choose the inequality that's in my problem. Okay? The inequality says y is less than or equal to negative 2x plus 4. I'm going to arrow down. Then I put in the next one. This time it's a greater than or equal to symbol. And I'm going to put negative 1/2 times x minus 2. The division symbol? Got it?
No. Hold on.
I get it.
And then arrow down.
Then arrow down and put in the last one. The last one gets a little tricky because not only are you changing your sign, but you're also changing your
Letter.
variable.
No, it's 2. See, the first one is less than equal to, the next one is greater.
X is greater than or equal to negative 2. Hit enter. You're done. You've put them all in, right? Can I hit enter?
Graph is blue.
Okay. So your graph is blue, but where the darkest blue lies, that's where your solutions lie.
Solution.
But, Miss Jones,
Yes.
how did you get your thing and change to X?
I arrowed over and deleted Y and put an X.
I
All right. Now, pay attention. We're going to do this line and this line just normal, which is where you press menu 6 4, right? To find the intersection. Because there's multiple lines, the calculator is going to ask you which graphs are you talking about. So I'm going to click this graph and I'm going to click this graph. And it says go lower bound, which means I go to the left. And it says upper bound, which means I go to the right. So where's my intersection?
4, negative 4.
4, negative 4.
Did you press your menu 6?
Yes, I did. All right, we're going to do menu 6 4 again.
Hold on.
Which graph y'all said?
How do we? What graph?
Mine.
Yes,
Which graph y'all?
the bottom two graphs. The two graphs that are at the bottom so that this could be possible.
So next we're gonna do, I see what we're doing.
I know some graph keep playing. I see what you're doing, but mine doesn't.
Give me a second to at least get through the problem, guys. At this point, can you let me get through the problem and I can come around and individually help? Because I'm not understanding where we're struggling. If this doesn't work for you, I want you to continue hand graphing. If this does not work for you, do not do this. Hand graph. If this is not your forte, hand graph. Period. So either be willing to follow along and figure it out, or use the word I can't and give up.
Do you have to drag the values?
Huh?
Do you have to move those lines?
No, I just moved it because it was in my way. Okay? So, I will go through the steps again if you give me a chance. But let me get through it the first time. Okay, I'm going on to the next intercept. Click the graph, click the second graph. Notice how it says first corner. The reason why it's saying corner is because I have an x value. I have a function defined by x. All that means is to press up, then press down. Down. Okay? Now, can I see my third x-intercept? My third intercept, I'm sorry.
No.
No. All you do is take your mouse, put it into open space. Pretend this is a video game. Pretend that this is a phone that you want to learn how to use. Take the mouse, put it in open space, and hold down your cursor until you have this little fist. And drag it till you can see the next point. Now you're going to do the same thing again. Menu, analyze graph, intersection. Click on the graphs I want to analyze. It says first corner, I'm going to go up. Second corner, I'm going to go down. And it tells me my last intersection is at -2, 8. Okay? Pretend that this is a phone that you want to learn to make your life easier, so you spend hours learning everything about that phone. If this doesn't work for you, please do it by hand.
So the little triangle ain't my triangle.
Excuse me?
The little bitty triangle.
No, my triangle is where all three of these vertices are. This darker inside, this is my triangle. Okay, so I'm going to do it again. And if you weren't paying full attention the first time, please pay attention now. I went to the home button. I needed a graph page that was empty. I pressed on the image that looked like a graph. Clicked it, and it opened up like so. That was step 1. Step 2 is I'm not dealing with equal functions anymore. I'm dealing with inequalities. So I'm going to delete the equal sign and plug in the inequality I need. My first inequality was less than or equal to. I typed in -2x plus 4. I arrowed down so that I can type in my next one. My next function was still not an equal, so I delete it out. Greater than or equal to -1/2 times x minus 2. If you are understanding, you may work ahead to problem 3. I'm going to arrow down again because I have one more function to put in. When I put in this next equation, I'm going to delete it out because it says greater than or equal to. But not only did that change, but the fact that it's not y. It is now a x. So I delete y and I put in x. So x is greater than or equal to -2. I have no more functions to put in, so I'm going to press enter. The dark blue region where these points intersect, that's where my function is. That's my answer. That's where my solution lies.
Do you still want us to sketch the graph?
Yes, please. Okay? So I look for the vertices. Please hope you're still following along, because if you can't follow along now, so I'm going to go menu, 6, 4. I click on one graph. I click on the other graph. Because it says first corner, that means I go up, then I go down. Next one, menu, 6, 4. I click on one graph, click on the other graph. When it says lower bound, that means I'm going left to right. So lower bound, upper bound. And it tells me I'm at Now, I can't see my next point, so if I click my cursor into open blue space, hold it till I get the dear life graph, I move it, and now I can do it again. Menu, 6, 4, one graph, another graph. First corner means I'm going up, then I'm going down. That is how I graphically with the calculator found my intersections. If this is not working for you, that is why you know how to do it by hand.
What do we do after we grab it?
What do you mean? We found the intersection? So I go to my paper and I'm going to write down my intersections. My intersections are -2, 8, -2, -1, and 4, -4. Okay? So that means that at these points, that's where my function is true. Again, if graphing with a calculator is not your strong suit, graph it by hand. There's my x equals, my x is greater than or equal to 2. Then I'm going to graph 4, -2. Is it -2 or +2? Okay? Ay. Up 2, down 2, over 1. These are hard to draw, so please don't draw with my judgment. And then I draw the other one, -2 something something. Is it -2 or positive?
-6 minus 7. Plus 7.
6 plus 7.
Okay, so I plug in for D. Is it 3x plus 7 or minus 7? Just 3x minus 7, why? So -62, 1, and 40. So what will be my max?
40.
When D equals 40. And what would be my min?
-62.
Now, you guys have to get this down because when we actually start doing the word problems,
Okay.
We have word problems with this.
All right. 3. 3 this time. How many systems do I have?
4.
Okay, I want you to solve 3 by how you're comfortable with. If you're comfortable with hand graphing, solve it by hand. If you're comfortable with the calculator, solve it by calculator. I'm going to go over it with you momentarily.